Saxon's Calculus Lesson 3 is a word problem review. So they just jump straight into their examples. Example 1, Diana could do 4 jobs in 7 hours. So we remember that it's the rate of, and then I usually use a little D or something that indicates their word, their name, so that it helps me. So the rate of Diana times the time it takes her to do something should equal the job that gets accomplished. So in the first part of this first sentence, Diana could do 4 jobs in 7 hours. If I fill that in and I solve for the rate, the jobs got filled in as 4 jobs and the time was 7 hours. So when I divide, her rate is 4/7. Repeating, Frank could do 7 jobs in 5 hours. So the rate of Frank is his jobs, which was 7, divided by his time, which was 5. Now I know both their rates. How many hours would it take them working together to do 10 jobs? So now my rate has 4/7 plus 7/5. That's them working together. The question is asking how long does it take for them to accomplish, and now the jobs is 10. So common denominator here is going to be 35 multiplied by 5, so 20. 35 multiplied by 7, 49. 20 plus 49, 69 over 35 is my time, times my time equals 10. 10 over 1 is a fraction, divide, so flip and multiply. 35 over 69. Time is, and I'm not sure I can reduce anything here, so 350 over 69, and the original was in hours, so this time is also in hours. All right, example 2. Get the page to turn here. Patricia could do 5 jobs in 10 hours. So the rate of Patricia is 5 jobs in 10 hours, and that's going to reduce to 1/2 for the rate of Patricia. One change to this formula as I read the equation. Patricia could do 5 jobs in 10 hours with 3 machines. So this is changing the formula from rate times time equals jobs to rate times time times people equals jobs. Normally it gives it to me in people, but in this case it's actually machines. So her rate is found at 1/2. All right, at the same rate, how long would it take her to do 4 jobs with 12 machines? No, her rate is not 1/2. Let me fix that. Let me go back here. Okay, so using this formula, I don't know her rate. Her time was 10 hours. She had 3 machines. Rate times time times equals the jobs, and she was accomplishing 5 jobs. Okay, now we're back. The rate then would be 5 over 30, because 10 times 3 is 30 divided, and that's going to reduce down to 1/7. No, 1/6. Knew that didn't sound right. Whew, okay, so the rate is 1/6. Now we fill that in here, 1/6, and it's asking for how long her time. She's changed her machines to 12, and she is accomplishing 4 jobs. Okay, so 1/6 times 12 reduces to 2t. And then we're going to divide 4 by that 2, so 2, and what was our time in hours again? So it will take 2 hours. Example 3. Walter and John found that the cost varied directly as the number who worked. All right, so this is the one where we do in the order, okay, it said cost varied. So cost 1 over cost from the second equation will equal, and varies directly means I keep the 1 and the 2 in the same spot over here. And that was very directly with the number who worked. So workers 1 over workers 2, but inversely as the Sabercat index. So I'm just going to use an S for that. And because it's inversely, you're going to flip-flop The second one goes in the numerator and the first one goes in the denominator. So the cost was, so now we have our formula, we're going to fill in our numbers. The first cost was 400 when 5 men worked. That's here for the first one. And the index was 8. So that goes down here on the bottom because it's the first one. And then the cost, no, I just read that. Index was 8. Yep. What was the cost? So they want the second cost solved for when 13 men work. So the second men is 13. And the index is 2. So the second index gets filled in here. And now this is a cross multiply. So I would just do this on my calculator and do 400 times 13 times 8 and divide that by 5 and divide by 2 or divide by 10, either way. But you should come up with the fact that the second cost is $4,160. Now, example 4. The cost varied linearly, that means like a line, with the number of men who worked. So instead of doing y equals mx plus b, we're saying the cost equals an m with the number who worked plus the b. All right, cost varied linearly with the number of men who worked. When 10 men work, the cost is $70, and I don't know the B or the M. When 20 men work, I still won't know the B. The cost is $120, and I still don't know the M. What is the cost when only 2 men work? So I need to substitute or eliminate together to solve for the M and the B. The easiest thing is to subtract and kill off the B's. Now I'm going to work backwards because these numbers are bigger, so I'm going to minus this set. So the B's are going to cross off. 20 minus 10 is going to leave me 10M here, and 120 minus 70 should leave me 50. Divide, so the M is 5. Use it to plug back in. I'm going to pick the smaller numbers to make life easier. So 70 equals 5 times 10 is 50 plus B. So B is minus 50, 20. Now we have it. Our formula then is cost equals 5 times the workers plus 20. Now we have the correct equation, and it says, what is the cost when 2 men work? So what is the cost when I have 2 men working? So 5 times 2 is 10, plus 20 is 30. So the cost is $30. And we've answered example 4. Example 5. When Luann, however you want to pronounce that, saw the bad men, it was high noon. When she caught them, I guess it would be Luann then, when she caught them, the hands of the clock made a 90-degree angle. What time was it when she caught them? Now, if you remember from trig last year, I gave you in my formula a shortcut whenever I'm dealing with a clock problem. And I know that like the rate of the big hand is 1, the rate of the little hand is like 1/12. The times are the same, but when I put them all together every time, what I always ended up with was 11/12 TB, and it just happens. And so I memorized this fraction at 11/12 TB equals, and the answer part is always the gap in the hands of the clock that they need to be moving. And since it says they were at noon, so if I'm picturing both hands together, and it then wants them at 90-degree angle, so it wants them moved basically to here, that's a gap of 15 minutes. So when I solve that, it will tell me how much the hands are moving. So I keep 15 over 1 times 12 over 11, because I'm dividing by that, it's going to flip and multiply. So 15 times 12, we get 180 over 11. And if I divide that out, it comes out to be 16 4/11 minutes. And that makes sense because as this little hand is moving, the big hand is also moving. So it's always going to be just a little bit more than what we expect the gap to be, the 15 minutes. because the hands have to move together a little smidge more to actually be at 90 degrees. Now, unfortunately, this is not the answer to the problem because the question said, what time was it when she caught them? So since I started at noon, my answer is it's 12 and 16 and 4/11. And then is that AM or PM? Well, since that's past noon, then it's PM. So this is the actual time that I will box.